Hi everyone, this is Dr. O. In this video, I'm going to talk about standardization and min-max normalization. When a dataset contains multiple variables, the scale of each variable can influence the distance measure and how we determine the similarity between two observations. For example, when you're comparing consumer information, data such as annual income, here as you see on the screen, tend to have a greater scale than the number of hours spent online per week. This is simply because of the fact that annual incomes are larger numbers. As a result, annual income will have greater influence on the similarity measure than the number of hours spent online per week. This difference in scale distorts the true distance between the observations and can lead to inaccurate results. Therefore, to make the observations unit-free, we use standardization or min-max normalization before we calculate the similarity measure for the data mining techniques. These transformation of numerical data ensure that each variable receives an equal weight when the similarity measure is calculated. One common way to standardize data is to calculate Z-scores. If you recall from the statistics courses, Z-score measures the distance of a given observation from the sample mean in terms of standard deviations. So let me quickly draw here a normal distribution. Let's say this is the mean. If your data has a z-score of 1, that means your data is 1 standard deviation above the mean. In order to find the z-score for any observation, we need to calculate average and the standard deviation of the variables. So we have here income and hours spent data. First, we are going to standardize income and then we standardize hours spent. In order to standardize observations for income, we first calculate its average and the standard deviation. Here, equal sign and then average. We select the data and close the parentheses. The average for income is $95,077 and the standard deviation for sample, and the standard deviation is 24,534.45. After calculating average and the standard deviation, we divide the difference between each observation and the mean by the standard deviation. For example, for Jane, we find the standardized income value as follows. Equal sign, the observation minus mean. Let's put this into parentheses. Divided by its standard deviation. And now let's fix the cell mean and standard deviation because we will use the same mean and the standard deviation to calculate standardized income for Kevin, Jennifer, Ken, and Jean. And click enter and drag down the formula. Based on the results, Jane's income is 1.247 standard deviations above the average income of all consumers in the sample. Kevin's annual income, on the other hand, is 1.189 standard deviations below the average income. Now let's calculate standardized hours spent. In order to calculate standardized hours spent, we need to first calculate average for hours spent. We can just copy this formula here, and also for standard deviation we can do the same. And you can see that average hours is 7 and the standard deviation is 2.9858. And to calculate the standardized hours spent, start with equal sign and open the parentheses. Hours spent minus average hours spent divided by the standard deviation of hours spent, and then enter. So we need to fix the cells C11 by F4 and C12 so that we refer to the same cell all the time, and enter. And now we can drag down the formula. Now you can see the standardized hours spent on the table. Now you see that on the table both income and the hours spent have similar scale, and therefore they will receive an equal weight when calculating the distance measure. Next, I'm going to explain another widely used transformation method, which is min-max normalization. In min-max normalization, we subtract the minimum value from the observation and then divide the difference by the range. And if you recall from the previous videos, range is the difference between maximum value and minimum value. This approach rescales each value to be between 0 and 1. In order to find the min-max normalized value for any observation, first we need to find minimum and maximum, and also the range for the variable. So let's calculate max for income. Max, open the parentheses, and then select income, and then close. Minimum, min function, and close the parentheses. Now the range is the difference between max and min. And for hours spent, we can just copy these formulas. In order to calculate normalized income, you type here equal sign and then select the observation minus its minimum value in parentheses divided by its range. And let's fix the cells here, B14 and B15. And then enter. And then you can drag down the formula. For hours spent, equal sign, hours spent minus minimum in the parentheses, and then let's fix C14 and then divide it by standard deviation and fix that cell as well, and then enter and drag down the formula. The min-max normalization rescales each observation between 0 and 1. Jane, with the highest annual income, has a min-max normalization income of 1, and Kevin, with the lowest annual income, has a min-max normalized income of 0. The min-max normalization values for hours spent are found similarly using minimum and maximum values of 2.5 hours and 10.1 hours respectively. As in the case of standardized values, the min-max normalized values have a similar scale, and therefore they will receive an equal weight when calculating the distance measure.